All right, guys, welcome back. We are continuing on with our discussion about OSPF. And we left off, we had quite a lengthy discussion. I don't think tonight's discussion is going to be quite as long, where we talked quite a bit about special area types and how we deal with traffic engineering in those special area types. Specifically, how do we configure OSPF not so stubby areas, and then also controlling NSSA redistribution. We talked about the P bit and being able to manipulate those values and so on. So our topic for this evening is default routing with the OSPF NSSA, which is actually going to include some of the topics that we talked about in our previous lesson. All right, so we're going to take a look at how default routing works inside of an NSSA. It's somewhat unique compared to some of the other special area types where we don't really have in the case of the NSSA, we don't have an automatic default route that gets injected into the area. So we have to decide how those default routes are going to be sent into the NSSA. And this is highly likely going to be one of those topics on the CCIE that they're going to challenge you on, because it is kind of a one-off with regard to the configuration, and they want to make sure that you're aware about how these one-offs work, okay? So we're also going to take a look at what is OSPF, what is the route type preference, specifically when it comes to redistributing routes. When we're dealing with kind of regular external or NSSA external routes, they get treated differently than, say, the standard Type 3 default route. And I'm going to demonstrate that concept in a little bit here. We're going to use the same topology that we were using in our last lesson. So let's take a look at that topology. We've kind of added to it over the last couple of lessons here. This is our topology that we're going to be working with. Obviously, this area here, area 2, is our NSSA, and we're doing some redistribution on router 5 and on router 3 of these EIGRP networks. Let's just make sure that we're actually still doing that redistribution, because I know from our last discussion, this was something that we kind of changed. So let me take a look real quick. Show run section router, pipe section router. And just kind of verify our redistribution process. Make sure we're just doing basic redistribution. So we've got area 2 configured as an NSSA. It looks like we don't have our EIGRP process running, and we do not have redistribution presently taking place. So let's go ahead and configure that. So router 5 is participating in domain 100, autonomous system number 100. Ethernet 1.2 is the interface that's participating in the 172.16.101 subnet. Let's make sure that that is configured. Nope, so let's go into interface Ethernet 1.2, IP address 172.16, and that looks like the 101 network. So we'll do a 101.5.0, no shut. And I believe we also had a loopback interface on this router. Let's do loopback. I guess 0 will work. Yep, interface loopback 0. IP address, we'll just call 55.55.55.55. And let's go into router EIGRP 100 and do a network of 55.0.0.0 and a network of 172.16.101.00.0.0.255. All right, so if I do a show run pipe section router, this router should now be an ASBR attached to the area. And it should be redistributing. Well, we're going to have to go ahead and set up the redistribution. So let's do in this case, trying to think if I want to do bidirectional redistribution or not. Let's go ahead and leave that off for now and verify some of the other configurations, because we did add this 16.16 link, which hopefully is still configured. But let's go ahead and check router 3, make sure router 3 has its appropriate configuration. Looks like for some reason the configs didn't save from the last session. So we've got loopback 100 is there. Yep, which should have been gone. Ethernet 1.1, not assigned. All right, so interface Ethernet 1.1, IP address 172.16.100, 3. No shut. Now let's do no interface loopback 100. And we need to go ahead and enable EIGRP on this interface as well. Router EIGRP 100, network 172.16.100.0. All right. Probably because I didn't save my configs the last time. And we'll do this EIGRP router here as well. Now let's do a show IP interface brief. Yeah, interface Ethernet 1.1. We'll do 10. And Ethernet 1.2. No shut, router EIGRP 100, network 172.16.0.0. So we should get a couple of adjacencies. Yep, we got our adjacencies there. Let me just check router 6 and router 1, because those again were other routers that we kind of modified the configuration on a little bit. Show IP interface brief. Oh, try that again. So config T. Interface Ethernet. Get there eventually. Let's try that again. Ethernet 1.1. IP address 172.16.36.2. And we're going to go to interface Ethernet 1.3. 16.16.2. Oops, that would be 252. And router OSPF 1. Area 2, NSSA, and network 172.16.0.0.0.0.255.255, area 2. So we should get an adjacency. Let me just check Ethernet 1.3 on router 3 here. One 172.16.36.1. IP OSPF 1 area 2. So I should get an adjacency on router 3 with router 6. We're just doing our basic configs for right now, just kind of getting everything working, making sure that all the interfaces are up and running. 36.1, let me do a ping to 172.16.36.2. Okay. Show IP OSPF neighbor. Yep, we're presently going through the negotiation, so that should come up eventually. And let's see our topology here. So it looks like this link was already original, this link was original, so let's go into router 1 and make sure that we've got 172.16.16.1. Interface Ethernet 1.3. 172.16.1.16.1. IP OSPF 1 area 2, no shut. Show IP OSPF neighbor. Relationship with router 3, but not router 1 just yet. Up, ping 172.16.16.1. Did I do the right interface? I believe I did. 1.3, 1.3. Up, 172.16.1.1. That's strange. Make sure these are the right interfaces. 1.0 to 1.3. 1.0 on router 6, 1.3 on router 3. All right, and we can fix that. Documentation is always helpful. Default, do show run interface Ethernet 1.3. Guess I should start the OSPF process as well. All right, so we should have all of our basic connectivity done at this point. Should get an adjacency. Now, if I ping 172.16, there we go, 16.1, all right. So we have our adjacencies. We're running OSPF in this domain between router 1 and router 3. Let's do a show IP route just to be sure. We are getting an N2 route, so there is some redistribution happening at one point. N2, remember, is a type 7 LSA that's coming into the domain, but we're not getting a default route. So our 198 network that's beyond router 4 is not going to be reachable at this point, and that's the default behavior. So it does look like router 3 has already got its redistribution configured. Show IP, or show run, pipe section router. And let's see if that is the case. Yep, we're redistributing EIGRP into OSPF, the subnets. I want to essentially do the same thing on router number 5 so that we have redistribution coming in from both sides. Router EIGRP, OSPF 1. And we'll redistribute the subnets. Okay, so we kind of went through and converged, set up our topology. We're doing redistribution from EIGRP into OSPF here. So we're going to be sending in a type 5 LSA into area 0 from router 5. Router 1 should have a route to reach this 172.16.101 subnet. Question is it going to choose that path over the R6 path? And we've already talked about that in our previous lesson, where what the route selection algorithm was. So if I do a show IP route 172.16.101.0, we can see that we're choosing the E2 route over the N2 route. And it has to do with the metric primarily in this case, because the N2 route is going to have a slightly higher metric, forwarding metric, than the E2 route, because we're adding the cost of the loopback, being that that is the address that's identified as the next hop, or the forwarding address for that particular prefix. So if I do a show IP OSPF database, NSSA external, I can see that we are learning about the 555555 subnet from router 3 with the forwarding address of 3.1. That's going to have a metric of 20. And then we're also learning about the 555555 subnet from router 5 has a metric of 20 as well, but the forwarding address is identified as quad 0, indicating that we are learning about these routes through multiple sources, through multiple ASBRs. We know also that an NSSA filters type 4 and type 5s. So if I go and look at my topology here, this is a normal area, ASBR in a normal area. And if I go to router 2 and I take a look at the routing table or the database in router 2, I'll be able to identify that, in fact, Tim just texted me. Recording again. If I do a show IP OSPF database, what I expect to see, because this is a router in a normal area, is I do expect to see type 4 LSAs, which are my summary ASB link state LSAs coming into area 1. R4 is being advertised as an external router. R5 is being advertised as an external router as well. If you recall, these type 4 LSAs pretty much allow me to identify how I can resolve the tree to be able to get to these ASBRs. And router 1 naturally is the router that's sending in those type 4 LSAs. And then in addition, we're seeing our type 5 LSAs. 55, 55, 55, 55 coming from router 5, and then the 100, the 101, and we're also getting a type 5 from router 4, because router 4 is an ASBR as well, redistributing 198.51.100.0. So this is a normal area. We would expect to see these type 5s, we would expect to see type 4s, type 2s, type 1s, etc. Even some type 3s as well. Summary netlink state LSAs are all my type 3s that are coming in from the other areas. In an NSSA, type 7s are not allowed. Excuse me, type 5s are not allowed. And because type 5s are not allowed, that means that type 4s are not going to be allowed either. Now we do allow the type 7s. We talked about the P bit being set automatically on a type 7 route, which allows the ABRs to then convert those type 7 LSAs into a type 5. Router 7, not router 7 in this case, but router, let me look at the topology. We don't have 7 routers. Router 3 and router 6 should not be able to communicate to this 198.51.100 subnet, because there's no reachability in the tree for that purpose. Now, if I was to change this to a totally NSSA, which is actually very simple to do, I just go into router 1 and router 5, and I modify the perimeter configuration. So let's do that. I'm going to go to router 1 and router 5, and I'm just going to configure this as a totally NSSA. Configure terminal, router OSPF 1, and we're going to do an area 2 NSSA no-summary. So that's saying that, no, I won't do the end just yet. So we're going to convert this area to a, of course, try that again. T router OSPF 1, area 2, NSSA, no-summary. Now, if you recall from our previous discussions, what that means is that we're not going to allow type 3s into this area now. Previously, type 3s were allowed, and there's kind of an exception to that rule. We'll talk about that in a minute, but now type 3s are not going to be allowed into the area. So essentially from router 3's perspective and router 6's perspective, nothing should be allowed into the area. You can see the previous routing table. We had several type 3's in the area, and we also see our type 7's. Now type 7's will still be allowed because that's by nature what a not so stubby area is. It is a special area type that has an ASBR which allows those type 7's. So these OIA routes should be gone, and all we should see is our connected routes, our local routes, and our N2 routes. Show IP route, and sure enough, all of the OIA routes are gone. But look what's being sent in by the ABR. The ABR is now sending in a type 3, believe it or not, even though type 3's are not really technically allowed, a type 3 default route. So there is now reachability from this network, from this device, to the 198 subnet. So if I do a ping to 198.51.100.1, we have reachability. All right, and the same thing would apply on router 3, show IP route. And that's simply because we converted the NSSA area to a totally NSSA, or an NSSA totally stubby area. Okay? So by making this just simply a not so stubby area, we're not going to be injecting the default route, and we're also not automatically injecting, we're not going to have a default route, I should say. We're not automatically injecting a default route, but we'll still have reachability to our inter-area routes based on the fact that summary routes would be allowed. All right? If I removed all of the summary address commands, actually that's already been done. All that stuff that we were doing in our last lesson with regard to manipulating the p-bit and creating these aggregate routes so that we can manipulate the p-bit, that's all gone because it wasn't saved. So we don't really have to take a look at that. All right? So if I was to take a look at the routing table for E1 and E2 routes, of course I wouldn't see any in this particular case because those would constitute type 5 routes that would have to come from area 1 or area 0. All right? If I was to go and look at router 4, well, actually, before I do that, let me go into router 6, show IP route, pipe include N2. So those are the 3 routes that we see on router 6 that are considered to be what we call not so stubby or N2 type routes. Coming from 36.1, looking at this topology, 36.1 is this link here between router 6 and router 3. So router 3, I believe, is originating those routes. Yeah, router 3 is originating those routes. Kind of makes sense. We're going to prefer, we're going to prefer this path to reach these destinations over, say, going through this path, going through another area, and then coming back in to the EIGRP domain. And that has to do with, reachability, right? From the perspective of, is this an intra-area external LSA, or is it an inter-area external LSA? We're always going to prefer intra-area advertisements over inter-area advertisements, regardless of whatever type of advertisement it is. All right? Now, if I follow the SPT, in the case of R6, if I'm looking at the SPT for 101, show IP OSPF database, let's do NSSA external 172.16.101.0. We can see that in this case, we're learning about this prefix from 2 different locations. One of the things that I want to point out here is that what we're learning from router 3 as the advertising router, number 1, the routing bit is set on this LSA. If you look at the one that's coming from router 5, the routing bit is not set. Also, type 7 to 5 translations are permitted here, whereas type 7 to 5 translations are not permitted here. That's because we've chosen to use this path over this path. All right? Now, if you look at the recursion process, if I'm going to, recurse the SPT, we will use a type 1 LSA to recurse to this type 7 LSA, as opposed to this case where I would have to recurse to a type 1 LSA to reach router 5, and then I would have to leave the area, go through area 0, and then come back in through the EIGRP domain. So this ends up being a better choice based on the logic that we talked about in our last lesson, okay? How does router 4 see these routes though? If I go into router 4, let me pull up router 4, and we take a look at router 4's database, or even just a routing table to start with, show IP route, we can see that essentially router 4 is going to see these routes as standard type 5 LSAs. Router 4 has no idea that these routes are coming from an NSSA. There's no indication that these routes were somehow translated from a type 7 to a type 5. And there's no way to really see that. If I do a show IP OSPF database, external, we see the 55, 55, 55, 55 prefix. That's the external network that's being redistributed. Router 5 is originating that prefix, but we don't see any reference here with, to a type 7 to type 5 translation. The routing bit is set, which means it's a usable route. There's a seed metric of 20, and if I do a show IP route, 172, let's do 55 since that's the one we were looking at. We can see that we've identified the forward metric as 10. That's what it cost me essentially to reach router 5. The overall path metric is 30 in this particular case. So other routers in other areas, and this would include router 2 and area 1 as well, are really just going to see these external routes as if they're just normal external routes. There's no idea or there's no understanding that somehow that these are somehow coming in as type 7s and being converted to type 5s. So we just follow the SPT to the ASBR. In this case, that's going to involve using a type 4 LSA to resolve to the ABR, using some sort of type 5 LSA to resolve to the external networks, and so on. In the reverse direction, the ASBR in this not so stubby area isn't going to get a default route automatically. We do already have external routes outside of the NSSA. One of the routes is coming from router 4, the 198 network that's on the internet. But we don't have reachability to those type 5s, and there are no type 4s within the special area type. So again, if I go to router 1, and I do a show IP OSPF database external, there should not be any. Oops, that's the ABR, sorry. And let me go to router 3. That's what I meant to do. Show IP OSPF database external. We're not going to have any external routes. And if I do a show IP OSPF database, question mark, also these ASBR summaries. These are my type 4 LSAs. I should not have any type 4 LSAs within the area as well. So ASBR summaries are the type 4s that allow me to reach the ASBR, and then the externals are my type 5s. Makes sense, right? It's a special area type that does not allow any external routes in, but we're also not setting in a default route, okay? Because the NSSA doesn't automatically generate a default route, we have to come up with a way of reaching these external networks that otherwise would not be reachable. And that's where we have a few options, and that's what this lesson is really all about. What are our options in reaching these external destinations? We did talk, and we actually looked at this the last time. I could change the area type, which I just did at the start of this process, where we do area 2 NSSA node S summary, which converts the area to a totally NSSA, and then automatically a default route will be injected. The other option that I have is to simply use the default information originate command. We actually looked at this in the last lesson, but I'll refresh your guys' memory. If I come into, let's go into router 3 and do it on router 3. Config T, router OSPF 1, area 2, NSSA, default information originate. Now I do have some options here. I can specify the seed metric for the default route. I can specify the metric type. I can do no redistribution, which would mean that if this is an ABR that goes into area 0 as well as into an NSSA, that we're not going to send the route into area 0. We're only going to send it into the NSSA. No summary, converting the area to a totally stubby NSSA. NSSA only means that we're going to limit the default advertisement into the NSSA area only. All these things we talked about in the last lesson. So let's go ahead and just generate a default route without any of the special options. Now if I go to router 6, I did that on the wrong router. Let's do that again. Router 3 is inside the area. Of course, we're not going to do well, I guess we could. I mean, if the internet was sitting out here in this EIGRP domain, we could inject a default route from router 3, but we wouldn't be able to do it with the area command. The only way you can do it with the area command is if the router's an ABR. We would have to do some sort of summary address, inject a default route using a summary address command. I'll show you guys that in a little bit here, but we want to do this on router 1 or router 5. Let's go ahead and do it on router 5. All right. So copy that. And we'll paste that there. All right. Now if I go to router 3, which didn't previously have a default route, if I do a show IP route, we can see that, in fact, a route is coming in from 13.1, router 1, that indicates a default route. Actually, I know why that's happening. We need to fix that. Show run pipe section router. Remember, as you're playing around with these configurations, make sure you take out your old configs before you start implementing some of the new configs, because you won't see the right behavior, what you expect to see, because you have some residual configs in there. For OSPF, we want to make sure that we're getting rid of the no-summary, because that's what's going to inject the default route automatically. So router OSPF 1, no, area 2 NSSA no-summary. So I have to take it out first. Then I reinsert area 2 NSSA. And we'll want to do the same thing on router 5, I believe. No, we're good. Oh, yeah, no summary is there as well, so it's kind of redundant, actually. Router OSPF 1, take out the configuration and put it back in without the no-summary. Understanding why, of course, we would have to take out the no summary if we're trying to manipulate how the default route gets sent into the area. Because with no-summary, we're changing the area type, we're changing the function of the area, which means that it's going to have a default route injected automatically. All right? No summary means more than that, right? No summary also means that we're not going to allow type 3 LSAs into the area. Okay? So the no summary does more than just send in the default route. It also filters out those type 3 LSAs from entering the area. And by this point, we've seen it so many times, at least that part of it you guys should feel pretty comfortable with. All right? The ASBR without the default information originate applied to the NSSA configuration, or without the no summary, the ASBRs are not going to know any other inter-area routes from every other router. They might learn what they know within the area, the type 7s and the type 1s and the type 2s. But if we go take a look at the OSPF database, if we had, say, for example, the no-summary configuration, we would see that LSA 3s, type 3s, would not be able to go from area 0 into the NSSA. If I look at what I've configured on essentially router number 5, if I do a show IP OSPF database, I can see that router 5 is generating a default route into the area as a type 7. Now, router 5 is a unique monster because it's participating in the backbone, but it's also participating in this special area. So it's sending in a default route as a type 7. We can also see that all of the other EIGRP networks, 55, 55, 55, 55, and 172.16.100 and 172.16.101, are being advertised by both ASBRs, or ASBRs in this case. Router 3 is an ASBR, and router 5 is an ASBR. Question is, how is router 5 recursing to the 55, 55, 55, 55 subnet? Hopefully, it's utilizing its local route to reach that destination. Show IP route, 55, 55, 55, 55, whoops. And we can see that we're actually using the connected route in this particular case. Naturally, that makes sense. Remember, administrative distance is going to trump all of these other selection mechanisms that we might have internal to OSPF. We're going to use the connected route because it has an administrative distance of 0. But we're also aggregating a default route into the area because we specifically identified that as part of the OSPF configuration. So run section OSPF, and we've configured the area as an NSSA with the default information originate option. So if I go over to router 6 and I do a show IP route, I can see that I am getting an N2 route. It's type 7, which is different, by the way. See, this is another thing that might happen on the written exam. They might give you a a routing table output, and then you're going to have to infer from that routing table output what's happening in the topology. They might say, because you should definitely be able to tell from this configuration that you're running an NSSA number 1, and that you're not using a totally stubby NSSA because the default route coming in is an N2, it's not an OIA. If this was a totally stubby NSSA, the default route would be automatically coming in as an OIA. And over time, you just kind of learn these things and you recognize them because you've seen them so many times. All right? What is the point, though? Right? Why are we aggregating this default route? Well, it's a matter of efficiency, right? We're basically trying to, the goal for any kind of stub area configuration or stub router configuration for that matter, or summarization for that matter, is to cut down on what we call the NLRI, network layer reachability information, the density of our databases essentially. If I only have one way in and one way out of an area, it's very simple. Simply use a default route to reach all of the prefixes that fall outside that area. It's a lot more complicated in our scenario because we have several ways of leaving the area, 3 different links with 2 different routers to leave the area. Plus, we're also doing mutual one-way redistribution presently on 2 different points in the autonomous system. So we have lots of reachability, lots of redundancy between area 0 and area 2, and we also have a lot of redundancy to reach those external networks. But that's where traffic engineering comes into play. And we're not actually done talking about traffic engineering. We're going to spend quite a bit of time talking a little bit more, well, actually a lot more about traffic engineering in our next lesson. I think you guys will find the next lesson to be extremely interesting and something that you've probably never seen before. All right? Okay? All right. Now, do we have a default route from both ABRs? Not in this particular case, because we're not doing a default information originate on both routers. You certainly could. And this is where you could start to kind of leak routes and maybe influence the path selection process by seeding those default routes with different metrics or different metric types and so on. So if I go into, we've already got the default route coming in on router 5. Let's get the same thing happening on router 1. I'm trying to think of what I want to demonstrate here with regard to the default route. This lesson, had the other lesson not gone as long because we were kind of exploring and learning interesting things, I would have kind of combined this lesson because it really kind of includes what we were talking about in the last section. But anyway, let's take a look here. So what I'm going to do is I'm going to go ahead and send in a default route from both ABRs. And then we have to go back and look at what the overall selection process is for the routers that fall within the area. So let's go into config T, router OSPF 1, and let's do area 2 NSSA, default information originate. We'll play with some of the variables in a little bit to see how we can influence this path selection. But now if I go to router 6, let me see. Try to think of which one I want. Router 3 is probably, nope. Yeah, router 6, actually either one would work. Let's go with router 6 for now and see how router 6 is interpreting this information. So if I do a show IP OSPF database, and I include, let's do a type, pipe 0.0.0.0 pipe summary, and let's see what we see. All right. So we're not getting any summaries. That makes sense because this is well, it's not totally NSSA, so we actually should be getting some summaries. I should do a begin summary. Let's do that. Let's do, let's just do a begin summary. Let's just do database, what the heck. All right, so we're looking at area 2 here, and specifically I'm trying to see or identify how I'm going to reach external destinations, right? I've got my summary net link states, which are my type 3 LSAs. I see I have reachability from multiple routers in this case. So both router 5 and router 1 are advertising those summaries. How could I tell which router I'm using to recurse those type 3 LSAs? All I have to do is simply go into the route and identify from the route what's being used. So if I do a show IP OSPF database summary, 172.16.12.0, and it's probably safe to say that they're all going to be the same based on our selection criteria. The routing bit is set to go to router 1, but the routing bit is not set to go to router 5. Any idea why we chose router 1 over router 5 in this particular case? It's actually a pretty simple concept. It's not very complicated. It's based on the reachability to the ABR, what we call the forwarding metric to get to the ABR that's advertising these type 3 LSAs. Forwarding metric here is 10. The forwarding metric for this path is 20. So 10 wins. It's quite simple. And that's what ends up going into the routing table. Show IP route 172.16.12.0. And we can see the metric is 20. We're learning this via OSPF 1. It's an inter-area route. We don't see the forwarding metric here because we would have to look at our type 1 LSA to identify how we're recursing to this ABR. Remember, the type 3 LSA only describes the external network that's being summarized, but we still would use our type 1 LSA to recurse to the ABR before we go on and route to the type 3 network. Okay? In essence, the path selection criteria can be a little bit complicated. Intra-area is always going to be chosen first. There's no complication there. Inter-area would be chosen second. then possibly E1, and then N1, in E2 and N2. All right, but an inter-area route will always win over an N2 route. No doubt about that. Okay? Because if I consider what's happening, I'm trying to think about this from the perspective of, let me see if there's another one I can show you guys real quick. So if I take a look at, yeah, I don't see them here because they're coming in as type 7s. We wouldn't see this in this case. Maybe on the other side of the area. What I was going to try to show you is that these inter-area routes are always going to be preferred over external N routes. All right. We have all of these different path selection criteria, all these different options, which can be very, very confusing because this doesn't exist in EIGRP. EIGRP is a relatively dumb protocol compared to OSPF, especially when it comes to traffic engineering. But we have all of these options so that we have the flexibility for traffic engineering. And I would say for you guys, this is the kind of thing that you would be tested on quite heavily on the lab. You know, not only ensuring that you have convergence between multiple OSPF peers, but that you have a way of manipulating the path selection process with those routers. Okay? So let's say we have an external router that represents some sort of internet connection. Maybe it's one of the EIGRP routers that's connected to the NSSA. Let's only redistribute OSPF into EIGRP, but not EIGRP into OSPF. All right? So let's go to router 1. Actually, let's go to router 5. Don't know why my greps are taking so long today. Config T, router OSPF 1, and we'll take out our redistribution here. We'll want to do the same thing on router 3. No. All right, so right now we don't really have anything happening from the EIGRP domain into the OSPF domain. But let's assume that we have some sort of default route or some sort of internet-based route on one of those EIGRP routers, and I want to be able to reach those destinations from my OSPF domain. But we're only going to redistribute in the opposite direction, OSPF into EIGRP, but not EIGRP into OSPF. So let's go into router EIGRP 100. There's a very specific reason why I'm going to show you this. Redistribute OSPF 1. And we'll do metric of 10,100. Reliability of 255, load, and MTU. All right? So we're sending those routes into EIGRP. Let's do the same thing from router 3. So if I go to the EIGRP router, I should have a bunch of DEX routes. So I've got routes to the 198 subnet. I've got routes to the 172.16.36.16. I'm essentially learning everything from 2 different sources. Now, if you look at my topology, it looks like I'm load balancing because I've got an Ethernet connection here and I've got an Ethernet connection here. We might have to manipulate that a little bit to send traffic in a specific direction because as of right now, this router, this is the router that I'm looking at, is load balancing the traffic into area 2. Could be a good thing. It depends on what the overall topology looks like. For us right now, probably not the greatest thing. But we will, it's not really the purpose of this exercise, right? It's to see how EIGRP reacts. We're trying to learn how OSPF reacts. All right. For the other direction, what we want to do is we want to take a default route from the internet and we want to advertise it into the OSPF domain. This is kind of like what you would do if you had an external BGP routing domain and you wanted to connect it to OSPF. You would simply inject a default route from that external routing domain into your OSPF routing process. All right? The question is, where do we want to do this? Would we rather have the default route come in from a router that's connected to the core of the network, or would we rather have a default route that for a router that comes in through a router that's connected to the edge of the network? In other words, is it going to be router 3, which is our NSSA router, or is it going to be router 5, which is, it's still an NSSA router, but it's also a backbone router. So let's go ahead and inject a default route from router 5. Now this is where you have to be a little bit careful because we're going to do something called a default information originate always on router 5. I know the internet shows that it's up at the top left. Let's disregard that for now and assume that the internet is on one of those EIGRP routers. So there's a couple places I could do this. Because we're kind of assuming that the internet is going to be on this EIGRP domain, let's go ahead and configure that on router 5. Router OSPF 1. Get there eventually. Default information originate. Always. So if I come over to router 2, show IP route, we can see that we're getting an E2 route. It's coming from 12.1. And if I was to do some sort of trace route to 55, 55, 55, 55, I have reachability to that destination. It's not part of OSPF because we stopped the redistribution into the domain by only doing redistribution from OSPF into EIGRP and not vice versa. All right, well that's fine, that makes sense. Router 2 is going to have a way of reaching the default route because it's coming into router 5. It's being sent into the backbone, actually it's originated at router 5, being sent into the backbone, being duplicated to router 1 and duplicated to router 2. Question is router 6 learning about this default route? Is it possible to use the default information originate command to send a default route into a special area type? I'll bet you I have an answer. Show IP route. And sure enough, we see the default route coming in as an N2. This is interesting because we're injecting the default route on the ABR that is attached to the NSSA. If I was doing this on router 4, which is only a backbone router, router 6 would not have a default route because type 5s are no longer allowed in an NSSA region. Does that make sense? So it does come in as an external route. If I look at any other router in the topology, we can see that the quad 0 route is going to show up in the other routers in the topology. All right. We've also spent a lot of time, guys, talking about this idea that just because it comes in as an external type 2, and just because, or in this case, an N2, let's go back to router 2. Here, it's coming in as an E2 with this seed metric of 1 in this case. That really doesn't matter, right? Because ultimately, what we're trying to do is trying to decide is how are we resolving the tree based on reachability to the peer that's advertising the route. All right? Oh, that's the forwarding metric that we talked about, right? The next question that we have to ask ourselves is how do we actually encode this route? How do we want to encode the route? Do we want to send it in as an E1? Do we want to send it in as an N2? etc. Or N1 or E2 or E1, whatever. We have those 4 choices, right? E1, E2, N1, and N2. The default behavior, as you can see here, is that it sends the route in as an E2. But what if there's another device that's also generating a default route? All right. So if I went ahead and removed the default route from all the other routers, and I wanted to do, say, a default information originate always on an internal NSSA router, it's not going to work. We're trying to get a type 7 default route from a router in the NSSA. All right, so what happens if I can't do a default information originate? By the way, let me show you that. The reason why it's working on router 5 is because router 5 is participating in the backbone. So that default information originate is being injected because R5 is participating in the backbone, and it's also participating in this NSSA. If I change this to a normal area, a normal stub area, as opposed to an NSSA, I would not be able to inject a default, a type 7 route into the area, and I would have to probably rely on that default route that automatically gets generated by the perimeter router. But let's say that Cisco says, you know what, you can't do any of that stuff. You can't send in a default route. You can't do a default information originate, always or otherwise. And you can't use static routes to reach these external destinations. This is the thing that I want you guys to really take away from this discussion today, and quite frankly, any other discussion that we have. You have to think about how to do things the way that they want you to do them. There's one story that I've always used to describe my experience with the CCIE lab. And the concept or the task that I was stuck with completing was really, really simple. Redistribute RIP subnets into EIGRP. And by the way, only redistribute the 5th subnet, the 7th subnet, the 9th subnet, etc. So I'm thinking, okay, that's simple enough. I'm just going to go ahead and create an access list or a prefix list that match those networks, create a route map, apply the route map to the redistribution process, done, right? Except they said, you know what? You can do all that, but your access list can only have one line. You can't use a multi-line access list. So guess what I was stuck doing? I was stuck having to calculate a bitwise mask that would facilitate the redistribution process that would only match the subnets that they wanted me to redistribute. Okay? So it's entirely possible that they're going to tell you you can do this or you can't do this based on how they want something configured, not just do it the quickest way possible or any way that's effective. All right? So what we're going to do in this case, what if they said we want a default route in the NSSA, but I don't want you to use NSSA default information originate on the perimeter routers. So let's go ahead and remove that from router 5. Shell run pipe section router. And I'm going to get rid of the this default information originate. This is the reason the type 7 is coming in. This is not the reason the type 7 is coming in. This is the reason that the type 5 is going into the rest of the areas, area 0 and area 1. But if I remove this line, we'll no longer see that type 7 our default route in the area. So let's just remove that one for now. And verify that the argument is solid. Go to router 6, and I should no longer see the default route. Let me see here. Should go away eventually. Let's go to router 5 and see what we're generating into the area. show IP OSPF database self-originate. I should not see, if I remember correctly, I should not see a type 7, right? So we're waiting for the convergence to take place, but this is another way of kind of confirming that that default route is no longer going to be sent into area 2 because I'm not seeing a type 7 anymore for the default route. So eventually what will happen is router 6 will lose its default route eventually. Seems like it should have happened quicker than that. Let me make sure router 1 is not doing the same thing. Well, I can already tell you it is, because look at the last command that I executed on router 1. All right, so do show IP show run section router. Yep. Router OSPF 1, and we're going to get rid of this default information originate as well. OSPF really shouldn't take that long to converge. It's not like a distance vector protocol. So these routes should be flushed out pretty quickly. Yep, there we go. All right. So we are getting a default information originate on router 5, which is sending all of the normal area default traffic to router 5 to go to EIGRP. But now we don't have a default route in our NSSA pointing towards the ASBRs. So how are we going to fix this? All right. How about we do a summary address in EIGRP pointing out a particular interface, advertise that summary route, and then redistribute that summary route into the area. So let's go into router 3. Make sure I'm doing this correctly. I'm going to do a summary address on this link, Ethernet 1.1. Default route pointing that direction. And I'm going to do a summary address on router 5 out of Ethernet 1.2 pointing in that direction. So config T, interface, Ethernet 1.1. And I'll do a summary address, IP summary address, sorry. In OSPF, it's just summary address. EIGRP 100. 0.0.0.0, okay, and I'll do the same thing on router 5. And let's go into interface Ethernet 1.2. All right. Now, if I do a show IP route, nothing has really changed from router 5's perspective. It's created this kind of default route that points to null 0 because of the way I generated the summary address. And that's not really the point. We don't really have an internet connection on this link anyway. Whenever we're doing a summary, we always create a null 0 route to match that summary. So we would hope that we would have some sort of connected route that would match the default route, the default network as well. We're not going to be able to test any reachability here because we don't actually have a default traffic. But my point is, I want to see what happens when I'm redistributing this route into OSPF. Is it going to include the summary route? I could even get really creative and only include a default route in that summary. So let's go in here and let's say IP access dash list, and let's do redis default. IP access list standard. Redis default. And we're going to do a match, not a match, permit 0.0.0.0 with an exact match. And then we're going to create a route map. We'll just call it the same thing. Redis default, permit 10, match IP address, redis dash def. Okay. Now I'm going to go into the OSPF process, and I'm going to say redistribute EIGRP 100 subnets using route map redis DEF. So I'm kind of going about this a different way. I'm creating a default route on the EIGRP router by creating an aggregate summary pointing out towards that interface. And then I am redistributing that route into OSPF because this is an ASBR. It should allow a type 7 default route to come in. So if I do a show IP OSPF database, NSSA external, I should see, ooh, it's not there. Why not? I wonder if I screwed up my route map. Let's just do this. Let me do a show, I don't care if we send the rest of the routes in. Let me do a show run pipe section router. And let's just do a redistribution without the route map. I'll go back and take a look at the route map a little bit later on, but config T, oh my goodness, router, OSPF1. Let's take out this redistribution command. And let's just do redistribute EIGRP 100 subnets. Show IP OSPF database external. And what I should see, NSSA external, yeah, there we go. I should see the routes come in, which includes the default route. You know what I might have to do? I might, oh, there it is. Ah, there's no, that's type 5. That's going into area 0. I think what I'm going to have to do, because it's a route that points to the null 0 interface, it's not included in the routing process. Because if I do a show IP route, let me try one more thing. IP route 0.0.0.0, 0.0.0.0, interface Ethernet 1.2. Oops, just Ethernet 1.2. Yeah, it's only going to send in routes that I'm using. So now you can see that my default route has been replaced. My default route has been replaced with my null 0 aggregate route being replaced with my static route. I'm curious as to why it wouldn't still send that in. Show IP OSPF database NSSA external. There's 55, there's 172. Still not getting that route. I might have to actually go to router 6 and see if it's coming in on router 6. Gateway of last resort is not set. So it's not working, and I'm not suggesting that it shouldn't work by default. I'm just trying to think about how I would describe the reason why it's not working. I could see how it would not work based on the null 0 route, because in the case of redistribution, I'm only going to redistribute routes that I can use. I'm not going to redistribute routes that are not usable. And a null 0 route is not usable, but I now have a static default route on router 5. Maybe if I get rid of the aggregate, we might have a couple of conflicting show run. Well, let's just do show run. Forgot what interface I put the aggregate on. I think it was Ethernet 1.2. All right, show IP that's 55. 198.
Do you need to get rid of the static route?
Well, this, yeah, you know what? I wouldn't be able to see it on router. Yeah, I wouldn't be able to see it on router 5. Because the static route is going to take precedence. I'm trying to think if there was a way. I was thinking to maybe show you a different way to send in this default route. And now I'm wondering if it would actually work, because now we're getting a little bit hung up on, is it going to be a local route to router 5? Is it being redistributed? And that's the part that I think is a little bit confusing here, because should it be redistributed? Let me do a show run section router. We did redistribute EIGRP as opposed to redistribute static. If I would have done a redistribute static, of course it's going to come in that regard as a type 7 LSA, but because it's not part of EIGRP, it's not going to work. That's why I wanted to create that aggregate address and to kind of simulate this idea. Let me do one more thing. I have an idea. I don't know if it's going to work or not, but let's give it a shot. Let's do a no IP route 0.0.0.0. You guys understand why the static route obviously is not going to work, because that's going to, first of all, it's not part of EIGRP. So the redistribution command with the subnets keyword on EIGRP is irrelevant. Now let me see if I'm even getting a default route from the other router. I am, okay? So I am getting a default route from the other router because it's advertising that aggregate that still exists on router 3. If you go into router 3 and you do a show run, include summary, we can see that this router is originating an aggregate default route and sending it into EIGRP. The question is whether or not that is going to be redistributed by router 5 because it's being learned through EIGRP into OSPF. Show IP OSPF database NSSA and negative. I'm just very curious as to why OSPF is not redistributing that quad 0 route. And I wonder...
Hey, Scott, can you go back to the topology?
Sure. So we're doing the aggregate default route in EIGRP on this interface. So that's being advertised over to router 5 as a default route. We are doing redistribution on router 3 though. But that still should come in as an NSSA external from router 5's perspective. Ah, I know why. I know why. Well, I have an idea why. Let me go back to router 5. If I look at router 5, the default route has administrative distance of 90 because that's being learned through internal EIGRP. It's not a redistributed route. It's a summary address in EIGRP, so it's going to have an administrative distance of 90. Router 5 is only going to redistribute the routes that it's using into OSPF, and it's going to choose to use the quad 0 route going...
Why would router 5 redistribute into OSPF? Isn't that router 3?
Well, we also have it configured on router 5.
Okay.
And that's what's kind of driving me batty here, because we have redistribute EIGRP 100 subnets in OSPF. So this route is being learned through EIGRP, thinking that it should be injecting that default route. Let's see if router 6 is learning the default route from router 3. It is not. So even in the case of router 3, that route's not being redistributed. All right. Let's table that for now. I don't think that's an appropriate way to do it anyway. I wasn't planning on doing it that way, but I thought, you know what, let's play around with it like we did the last time and see if there's kind of a different creative way that we can inject this route. There are easier ways, there's no doubt about it, right? Why do it the hard way when I can just go ahead and do an Area 2 NSSA default information originate at the ABR and be done with it? And I'm going to send in a default route from the ASBR. In fact, let's go ahead and do that. All right. Let's get rid of the, well, we don't really care about the aggregate route. Let's go ahead and do our default information originate on the NSSA routers or the ASBRs. Area 2 NSSA default information originate, and on router 3. All right. If I do a show IP OSPF database NSSA external, there's a couple things that should be identified here. Let's go to router 6 since that's kind of a neutral router. Show IP OSPF database external 0.0 or NSSA external, sorry, 0.0.0.0. And we can see here that the routing bit is set from router 3, so we're accepting the default route from router 3. The type 7 to type 5 translation is allowed as well, which means that we can convert those, the P bit is set essentially. But we're choosing in this particular case, the route based on the route type, not the route metric. All right. Well, in this case, there's a tie. So how can we change that? How can we make I'm trying to think. We looked at this yesterday. And I'm trying to think about how we could do E2 versus N2.
E2 versus N2. Hey, Scott?
Yes, sir.
Sir. So if we were talking about getting EIGRP to propagate, do we need to use the default network command?
Well, there's a couple ways that you can do it.
There's a couple ways that
you can do a default route in EIGRP. The default network command is not really the preferred option. The best way to do a default route, inject a default route. I'm getting a lot of feedback, Tim. Can you go ahead and mute real quick? Thanks. The best way, I think, to get a default route into EIGRP is to have some sort of static default route inside of EIGRP or inside of an EIGRP router that gets redistributed into the EIGRP process as a DEX route. That's typically how we would do it in an EIGRP domain. So we could do that on the EIGRP router. Create a static default route on that EIGRP router, redistribute static into EIGRP with a seed metric, and then OSPF would probably send that route into, because that's now part of the topology table, it would, and the routing information base for EIGRP, it would send it into OSPF. All right. Okay. Let's look at the topology because there's a couple more things I wanted to show you before we kind of wrap this up. If I'm presently injecting a default route from router 5 into the NSSA, and I'm sending in a route from router 3 into the NSSA, a default route. Router 6 is going to prefer the path through router 3 because it's an intra-area external route. And we certainly, if we shut down the link between router 3 and router 6, would still be able to route through router 1 to get to the default route that's being sent in by router 5. In order for us to effectively test whether an N1 or an N2 would be preferred, we would have to have another link between router 5 and router 6. I don't think I want to create that right now. But we talked about this yesterday, in our lesson yesterday. The p-bit gets set. That indicates that this is a route that can be translated. We're going to choose a route based on the route type, not the route metric, typically. Do I prefer an E2 over an N2? The order is actually supposed to be O, then OIA, then E1, then N1, then E2, then N2. But I'm only going to take, and we learned this in our last lesson, I'm only going to take an E2 route over the N2 route if the forward metric is the same for both of those particular routes. We're only going to choose that E2 route over an N2 route if the metric ends up being the same for both the forwarding metric, not the seed metric, but the forwarding metric ends up being the same for those particular routes. We already identified that this is really not clear in the documentation, and even Tim identified the fact that it does also depend on the it depends on the iOS version that you're running as well. All right, it's not the cost of the route that matters. It's how we recurse the tree. What is the cost to the ASBR, and that's what matters. Most books are going to say that a metric type 2, an E2 or an N2 route is not going to increment the metric, but that's actually technically wrong. So we're sending in, for example, as a default, in this case, we're sending in, if I do a show IP route 0.0.0.0, we are sending in this route through OSPF. It's coming in as NSSA external type 2, and it has an initial metric of 1, a seed metric of 1, but the forward metric is 11 from router 6 perspective. If I do a show IP OSPF database, NSSA external, we can see that default route is listed here as well. Router 3 is advertising it. P-bit is set. This is the route that we're using. The metric is 1. But I'm also getting this route from router 5. No type 7 to type 5 translation is allowed. The p-bit is not set. And that was done automatically, by the way, because we didn't choose this path. And router 5 also happens to be sending this route into the backbone anyway. So it's saying, you know what, I'm already sending this route into the backbone. I don't need some other crazy ABR on the network also sending this route into the backbone, which is why we set the p-bit, or turn the p-bit off in this case. So we have to figure out how do we recurse to router 5 and how to recurse to router 3. That will tell us, if I do a show IP OSPF database border routers, or show IP OSPF border routers, how do I recurse to those perimeter routers? It's going to cost me 74 to get to router 5, and it's only going to cost me 10. So I'm going to use that as my forwarding metric, and that's what's going to allow me to decide whether or not I'm going to choose an N1 versus an N2. How could we make the route coming from router 5 an N1? All we have to do is, in our redistribution process, with our default information originate command, just change the metric type to type 1. All right? So now if I go back to router 6 and I look at my NSSA external routes, I still see essentially the same information. This is coming in as the prefix. The link state ID is always the external network number. But now this is coming in as a type 1. The routing bit now is set on this LSA, which tells me what from router 6's perspective? Any thoughts? We still can't do any 7 to 5 translation, but that has to do with the fact that router 5 is an ABR participating in area 0. But it appears as though I'm now using the path through router 5 to reach that destination. If I do a trace route to 198. What is the address there? 51.100.1. I have reachability going through router 6. Looks like I'm actually taking the EIGRP path. But from an OSPF perspective, it looks like I'm trying to go over to router 5. So that's kind of interesting. Show IP route. We have a gateway of last resort set to 36.1. Because we're originating that route in EIGRP. It has a lower administrative distance than OSPF. Let's get rid of that. Show run interface Ethernet 1.1. Get rid of that. See if that changes router 6's behavior here. Well, let's go back and check router 3's default route. All right, so now router 3 is getting its route through 131.1, which makes sense. That's the serial link. That's how OSPF was learning about that anyway. We're getting an N2 default route from router 3 because we're sending a default information to originate from router 3, but it looks like router 3 is ignoring that. Did we do an always on that? We probably didn't do an always. But let's go check router 6. Show IP OSPF database. Actually, let's do show IP, yeah, database NSSA external. And the routing bit is still set on the route. Where's my default? There it is. The routing bit is still set on the default route that's coming from router 5, which has a metric of 1. That's the seed metric. But then again, we have to recurse to router 5 to be able to find out what the overall forwarding metric is, which is going to be 64 or 65 in this case. All right, I think, maybe I'm not explaining it very well, but I think you guys understand what we're talking about here. We need to check the shortest path to the ASBRs first. And once we've identified what the shortest path is to the ASBRs, then we can recurse to the default route that's going to be selected for that particular path. All right. I guess that's about it. I don't know if you guys have any other questions or suggestions on maybe some different configurations that we can play with in this particular lesson. I'd be more than happy to kind of play around with some configurations. I encourage you guys to do the same thing. Absolutely. Ken mentioned in the Slack messages, the Slack group, that he went back and watched that video from last week, or what was that? Monday. Was it Monday? No. And found it very interesting. Yeah. Go ahead, Tim.
Oh, yeah. So I was just looking at trying to get EIGRP to redistribute, and it looks like that different routing protocols used, they need to have the default route listed in different ways.
Right. That is very true.
Right. That is very true. So let me go pull it up again.
And EIGRP is actually kind of unique because it's a distance vector protocol.
It says you got to redistribute as a static.
Yep.
So you actually do the router EIGRP and then redistribute static, and then you should be able to redistribute into OSPF. I don't think we did that, did we?
No, but that's what I was describing before. So let's say, go ahead and mute, Tim, and I'll show you what we're talking about. So let's say that we had a default, we had the internet connection on this router here, this EIGRP router, all right? And I'll just create a dummy default route. Interface loopback 0, IP address 1.1.1.1, 255.255.255.0. All right, and I'm going to do an IP route 0.0.0.0, 0.0.0.0.0, 1.1.1.2. Okay? So if I do a show IP route, because that loopback is active, the route's going to show up, not going to go anywhere. But then I can go into router EIGRP 100, and I can do a redistribute static with a seed metric, 100, 1, 255, 1500. And if I do a show IP EIGRP topology, I should see that quad 0 route is listed in the topology database as a redistributed route. If I go to router 5, I should see that in there as a DEX route. There's my gateway of last resort listed as a DEX route. Now, because I'm doing a redistribute EIGRP subnets into OSPF, that route should go into the domain as to the OSPF domain as a type 7 route. I would still have to get rid of this part of it. So let's go ahead and do that. And let's do no, oops, and area 2 NSSA. Let's do the same thing on router 3. And this is a pretty common way of doing it. You can use the default network command, but it's very confusing, that default network command. And all the years I've been doing this, default network command has always kind of eluded me with regard to its purpose. It's not very conducive or very intuitive, if you will, using it. So I tend to kind of redistribute default routes into EIGRP this way. So if I do a show IP OSPF database external now, NSSA external, I should see, let's just do a show IP OSPF database. Show IP OSPF database. I should see type 7s coming in. Still not seeing a type 7 for the default route. EIGRP topology. Do we have the default route here? Yes, we do have a default route. It's part of EIGRP. Do show run section router. So this is strange. We are redistributing EIGRP subnets. The default route is part of EIGRP. We're not doing subnets. Maybe that's the reason here. I don't know what that other N was. Show run section router. Okay, that would probably work anyway. Show IP OSPF database. Why are we not seeing the type 7s? Let me try this one here. You guys understand what I'm saying here, right? So it seems to me like regardless of whether or not this is a special area type. So this guy is sending in, well, it's sending in the default route as a type 5, but it's not sending in the default route as a type 7. So there's something strange going on here that's disallowing that default route to be redistributed as part of the EIGRP redistribution process. And that is probably one of those little caveats that we would have to look up. Do show run pipe section router. Redistribute EIGRP 100 subnets. And if I do a show IP EIGRP topology, we should see the default route here as well. So that's a little perplexing. Why is that default route not being sent into the NSSA? It's definitely being sent into, well, actually, you know what? I've got the default information originate always on there. So that's probably why that default route is going into area 0. Let's take that off. And show IP OSPF database. That won't affect the type 7. But yeah, so the type 5 is still going in. No problem. We're still sending in the type 5 route, but we're not injecting the default route into area 2. Very curious why that's happening. I'm seeing all the other prefixes, the 55 prefixes and the 100 and 101 prefixes, but I'm not seeing the quad 0 prefix. And I'm wondering, I'm going to test one more theory here. IP route 44.44.44.44. Let's just do this. I wonder if it has to do with subnet. I wonder if it has to do with show IP EIGRP topology. Did I do it on the wrong router? Should see 44. Yeah, there it is. Okay. Whether it's a default route or the fact that it's being redistributed into EIGRP first, and because it's a DEX route, it's not going to be allowed to be redistributed into OSPF. Nope, there it is right there. So that's really, really interesting to me. We're essentially injecting the 44 network the exact same way that we're injecting the quad 0 network on that EIGRP router using redistribute static. The static route's even pointing to the same loopback interface, but the 44 is being sent in, but the default route is not being sent in. That's very interesting.
That's very interesting.
So, okay, this is router 6, okay.
Yeah. I was just seeing if router 6 was actually seeing that 4444 subnet that I injected into EIGRP using the exact same process as the quad 0 route.
Can you go back to the EIGRP router and do a show IP route?
Sure. Static route. There's the 44. There's the quad 0. So go ahead.
No, I'm just, I was thinking out loud. So yeah, it doesn't make any sense. That should have been redistributed. As long as you had that redistributed static command in, you should have been able to pull it into OSPF.
Agreed. And because, so there must be something in OSPF that is preventing that particular default route from being sent into OSPF. That'll be your homework assignment to figure out why. No, kidding.
Well, if you use the network statement instead of the IP route, you know, doesn't that take precedence?
The network statement in what sense?
The network statement in what sense?
That if if another route isn't found, then it would try to use that one. No, I guess it wouldn't matter for redistribution.
Right, because network statements would be if we wanted to include an interface or a network in the EIGRP process. But we're already inserting these routes into the EIGRP process through the redistribution process. And there's nothing to put a network statement on anyway. The loopback interface, we could put the loopback interface in EIGRP, but that's not going to affect our default route.
So is OSPF, if we go back, is OSPF advertising a default route? Like if we go back to router 3 and router 6?
No.
Is that advertising anything else?
You're talking about router 5 and router 3, right? So if I do a show run pipe section router, I took out the default information originate and also the default information originate always. But this is what's interesting about this. The default route is going into, dang it, I thought I removed that. This would not affect the NSSA, but it might negate the default route even getting into area 0. Show IP OSPF database. Yep, see now we've lost our, no, we still have our type 5 going into area 0. So if I go to router 4, I still have a default route coming from router 5. Nope, that's a static default route going out to the internet. Let's try router 2, because router 2 is in a normal area as well, and it's not going to have a static default route. Yep. So it looks like the default route is being ignored completely in the redistribution process. It's not even going into our normal area, because router 2 would have a default route if the redistribution was taking place. I'm seeing on router 5, well, actually, you know what? Show IP OSPF database. Let's see how we're recursing to this destination. Never mind, it's gone. Okay. So it's gone. It's not even going into the database. Even though redistribution is taking place, somehow that default route is not being redistributed. And that's got to be by design. I'm just trying to figure out why. The 44 is, as a type 7, which is what we would expect. Although the 44 is not being sent into the backbone. Probably because it's being sent in the backbone from router 1. Quite the conundrum. If we have some time to play around with this, I might play around with it a little bit later tonight, see if I can kind of get it to work. I don't think it's that important. From the perspective of EIGRP, I think it's just one of those weird things where you kind of want to figure out why it's not doing that. What rule is built into OSPF that says, we're not going to go ahead and redistribute the quad 0 route, but we're going to go ahead and redistribute the 44 route from into OSPF.
I think I just read that EIGRP will not redistribute it unless the default route is directly connected.
Unless the default route is directly connected. You mean the static default route points to a connected interface?
Yeah.
Okay, well, we can test that theory. Well, you're talking about the default route would have to be on router 3. Or are you talking about on the EIGRP router that would have to point to a connected interface? Because we do know...
The EIGRP router would have to point to a connected interface. So it has to look like it's something that's valid in order for it to redistribute.
Well, it has to be a route that's used. There's no doubt about that. EIGRP will not redistribute something that it's not using. And it is in our routing information base. So it is definitely being used. But let's go ahead and test that theory. Show run, include IP route. Because I can point it to loopback 0 just as easily as I pointed it to 1.1.1.2. I believe it's loopback 0, yep. So let's do config T. All right, so now it's directly connected to loopback 0. Still no gateway of last resort. But if I go to router 3, I should have a gateway of last resort that's coming in as a DEX route. So I know that the default route is getting to the other routers. So I know it's being advertised. But well, I was going to say it has to do something with whether or not OSPF is going to allow us to redistribute external routes from EIGRP. But if you go to router 6, that cannot be the case because 44 is an external route in EIGRP and it's being redistributed just fine. So there's something about OSPF that says we're not going to redistribute a default route in EIGRP into OSPF, even if it's a valid route within EIGRP.
You just ran that command again. It looked like you just went in.
Sorry?
Sorry? Did you run that command again, or did you just flip over it? I didn't see a refresh on the screen.
I just ran the command again.
Oh.
Yeah. You mean the IP route command?
Yeah, I'm sorry. It didn't look like nothing. It didn't look like anything changed on my side. I was like, ah.
Yeah, I was just quick, man. I'm just quick. Well, not on everything, but most things. So that's just really interesting. There's got to be logic to it. There's got to be a reason to it. It's kind of one of those things where, yeah, we're not going to do this because this, and we don't know what that is. I've never tried to do this in a topology, so this is a new. Maybe it has to do with the state machine, the path selection process, or path selection rules that OSPF uses. Not sure. All right.
Well, thanks for taking the time to try to figure it out.
Yeah, I might still play with it, might not, depending on how quickly I can get my other stuff done.